let's do some examples. First up is this one, example A. So the directions are going to be the same. We'll do 3 examples, same directions each time. Find cosine of theta and tangent of theta using the given information. Construct a reference triangle. So first thing we have to do is figure out which quadrant we're going to be in. Then we can draw a reference triangle and go from there. So in order to determine the quadrant, we need to know the signs, positive or negative signs of the trig ratios that we're given. So sine of theta is 3/7. We'll use those numbers in a minute, but to start with, we just need to know that sine is positive. Tangent, it says, is less than 0. That's going to be negative. So I got a positive sine and a negative tangent. That is going to put us in the S quadrant, quadrant 2. So the upper left quadrant of our unit circle. So now I will draw my reference triangle. So start at the origin, and then in order to get to quadrant 2, I'm going to have to go left across the x-axis. I don't really know how long to draw this. This is not going to be a like to scale drawing. It's going to be qualitatively correct. I know I need to go into quadrant 2, so I'm going to go to the left a little ways, not all the way out to the edge of the circle. Here's my second vertex of my triangle. Turn with the right angle and go straight up. Third vertex will be on the edge of the unit circle, and then I can draw my hypotenuse. Here's my graph walker to keep my perspective correct. So sine, that's the ratio is the opposite over the hypotenuse. So that 3 will be the opposite, and the 7 is the hypotenuse. So I'm going to use those to label my triangle now that it has been drawn. So 3 is the opposite, 7 is the hypotenuse. Next step in this process is going to be to find the length of the third side of the triangle. So use the Pythagorean theorem. I'm going to call this side x since it's the x component of my vector. So I got x squared plus 3 squared equals 7 squared. Let me give this a little bit more space. So x squared plus 9 equals 49. Subtract the 9 on both sides. X squared is 40. And then x equals radical 40. So I could reduce or simplify radical 40. You don't have to. The warm-up assignment will not mark you wrong if you have not simplified the radical, but of course it is good mathematical practice. So I know that 40, square root of 40 is the same as the square root of 4 times the square root of 10. I've chosen to use 4 as a factor since it is a perfect square number. And now the square root of 4 is equal to 2, so this will be the same as 2 radical 10. If you want to use radical 40, that's totally fine. Like I said, you won't be marked wrong for that. Whoops. I'm going to label that side length as 2 radical 10. And now that I have all 3 side lengths, I can construct the trig ratios that the directions asked me for. So I was asked for cosine of theta. Cosine is the adjacent side over the hypotenuse, and now I know the length of the adjacent side is 2 radical 10. So I'm going to 2 radical 10 as my numerator. Hypotenuse is 7. And then I got to stop for just a second because I remember in quadrant 2, sine should be the only positive trig ratio. And it seems like I've just written a cosine that's a positive value. And I don't think that's the way it should be. It's not. That's not correct. So before I finish, I need to double check this. If I'm looking at my reference triangle in the unit circle, I'm in quadrant 2. That's to the left on the x-axis, and left on the x-axis means that my x-coordinate should be negative. And I didn't label that earlier, but I'm going to go ahead and put that negative sign on the adjacent side because of the context of the graph. The unit circle is always on a graph, and on the left side of the x-axis, any x is going to be negative there. So I'm not saying the length of the triangle is negative, because length can't be negative, but the coordinate of that ending point, the terminal point out there on the unit circle, would have a negative x coordinate. And I need that negative sign also to show up in my cosine ratio. So my cosine, negative 2 radical 10 over 7. And then the other ratio I'm asked for is tangent, which is opposite over adjacent. So now I've got the negative signs figured out. So 3 is the opposite side, negative 2 radical 10 for my adjacent side. And you could move the negative sign out in front. It does make our trig ratio look a little bit nicer. Let me write tangent down here. Okay, and there we go. I got the cosine, I got the tangent. If I needed to write all of the other trig ratios, I could. I have all the information. Just the directions ask me specifically for these two.